Alrighty, so let's then get into what we're going to do today. The good news is we're going to do today, it's not too much new stuff. We're just going to kind of make sure we're ready for graphing those polynomials. Okay, that's going to be like the major thing that we look at today. All right, graphing the polynomials. Again, just kind of continuing with that. I'll give you a few to then try on your own, and then we'll get started on the homework. Okay, so it shouldn't be too intense today. All right, which may be a good thing. Don't forget there's also TenMarks, okay, as well, right? So don't forget you're getting that 10 mark. Make sure you're getting that TenMarks done. That's due by this evening at like 11:59 p.m. Please don't wait until this evening to start it, because don't tell me, oh, Mr. Wid, I couldn't log in last night and stuff like that. Take care of that now. Make sure you know how to log in. No, you can recycle that. Yeah, thank you. Okay, so like I said, we're going to be re-examining graphing polynomials, just to make sure we're okay with it. I'm going to do 2 together with you, then I'll give you guys 3 to do, and then we'll kind of cut you loose on the homework. That's not going to be too intense, like I said. So day 2. All right, so this pen's dying. Okay. So again, we're just going to sketch a graph. Of the polynomial. All right, so here's our example. Y equals, we'll say x minus 2 times x plus 4 squared times 2 minus x. Okay, so there's our polynomial. Nice and factored for us. All right, so we don't have to worry about that. And again, we're going to do the same things to kind of identify those same pieces of information, right? We want to be able to find the zeros. Okay? We want to be able to find the middle behavior. Okay, what I call the middle behavior, right? It's just what happens like between the zeros. Bless you. And then we'll, of course, examine the end behavior. Okay, and that then gives us a pretty good idea to allow us to then finally sketch. Okay, a graph. And the reason for that is because we already kind of have a good idea about what polynomials look like, right? They kind of like are sometimes have some bumps and valleys, or hills and valleys and stuff like that, but for the most part, they'll have end behavior that goes up or down, and then left or right behavior that goes up to infinity or down to negative infinity and stuff like that. So, anywho, let's find those zeros, right? So we set this thing equal to 0, right? To find the zeros, exactly right. So step 1 here. And again, I'm listing these steps out explicitly. You don't need to actually list these out when you're actually doing the work, right? This is just for your notes, for your organization. You just need to do this stuff, okay? But I'm just doing this right now for your benefit. Okay, so we'll set this function equal to 0. And so then we have the zero product property we can utilize here and say x minus 2 is then 0, x plus 4 quantity squared is 0, 2 minus x equals 0. So that gives us x equals 2 here and x equals, 2 there as well. And then what do we do for x plus 4 quantity squared equals 0? How should we go about solving that? What should be our first step there to solve that? Square root both sides, right? And when we square root in an equation setting, we normally want to put a plus or minus, but when you square root 0, it's just 0. There's not really a positive or negative 0, so we can just say x plus 4 has to equal 0 there, right? There's no plus or minus 0. We don't have to worry about that. Right, so we get x equals negative 4. Okay? So we really only have 2 zeros. We have 2 zeros here, right? 2 and negative 4. So we'll go ahead and again, I like to put these in order here. So let's see, negative 4 and 2 are my 2 zeros. And so I'm going to pick a number there between negative 4 and 2. What might be a good idea there? 0, sure, 0. Negative 1, right? If you want to pick something that's like exactly in the middle between the two. So let's try 0. 0 is pretty easy to do. So let's see here. Let's evaluate y at x equals 0. Okay, Okay, so it's going to be negative 2 times 4 squared times 2. Okay. And so that's negative 4 times 16, this would be negative 64. Okay, so we have the point 0, comma negative 64. Okay. And then the end behavior. Okay. So end behavior, right, as x approaches infinity. Okay, f of x, or maybe I should say y in this case, but oh well, I already wrote f of x, so I'm going to keep with it. Okay. So what do we look at when we determine the end behavior of our polynomial here? What are we looking for? Two things, right? What two things? When we determine the end behavior of polynomial, we're looking at the degree and the lead coefficient, the sign of the lead coefficient here. Good. Okay. So looking at our polynomial there, what is the degree of this polynomial? Two, three, four. I hear 2, 3, 4. 4. Okay. So it sounds like the majority of the voices are 4. All right, but I don't understand. I see x times x times x, right? X times x times x. That would be x cubed. Where are you getting the degree 4 from? Right. The x plus 4 is being squared. So there's really two of those, right? If you wanted to write it out, you could write x minus 2 times x plus 4 times x plus 4 times 2 minus x. So there's really 4 x's that are getting multiplied together there. Yeah, so it is a degree 4. What is the lead coefficient going to be? Positive or negative here? Yeah, so let's see here. So we have a positive 1. The 1 here in front of the x is going to be squared, so it will also be a positive 1. And then what's the coefficient here? Negative 1. So it's a positive times a negative lead coefficient. Okay. So I'll say lead coefficient less than 0. Okay, so degree 4 means that they're both going to go, either the left and the right will both go to positive infinity or they'll both go to negative infinity. So that lead coefficient means they're both going to go to negative infinity there. Okay, both go to negative infinity there. All right. And so now we'll sketch. I'll put the sketch over here where we got space. So again, kind of considering what I have to include here, right? My x values, they're not too crazy. I have to go from negative 4 to positive 2, so I can probably just count by 1s on my x-axis. For my y-axis, I might count by 5s. I think I'm going to count by 5s. I think that I should be able to get away with counting by 5s there. So let's see. So I don't have to go really negative. I have to go very negative there. So I'll kind of like draw my x-axis a little higher than the center of my y-axis, right? Normally we draw it kind of like a plus sign there. Let me do it like this. Okay, knowing what I have to graph. And again, I'll count here. So 1, 2, 1, 2, 3, 4. So we have the, and maybe I'll use a different color for this as well, since make it stand out. So negative 4, 1, 2, 3, 4. And then positive 2, 1, 2, like that. And we're going to graph the 0, negative 64. So let's see if I can do this. 5, 10, 15, 20, 25, 30, 35, 40, 60, 65. Okay. So it's going to be something like that right there, we'll say. And again, this is like count by 5s. Okay. Again, please indicate at least one, number there on your y-axis if you're counting by something other than 1s. Okay. And now we'll just connect the dots. That's easy enough here, right? We got to go down to this, and then up to that. Okay. And again, we might be tempted. Some of you are going to be tempted, right, to just keep on going through, right, and just up and up. But we know that our end behavior here is they both, as x approaches infinity, that is as far we go far to the right, we're going to go to negative infinity. As we go far to the left, we're going to go to negative infinity. And so that means from here, once I hit the 0, which way do I need to start going? Back down again. I got to turn around and boom, go down. All right, and then same thing right here, right? I'm going as x approaches negative infinity, that is as we go further and further to the left, f of x should also approach negative infinity. So as I go further left here, I need to hit the 0 and then go right back down. Okay, and so there is our graph. Yes?
Isn't it true that if you have like two of the same numbers, because we only had two numbers, but the degree was 4, that they double bounce, or they bounce off the other?
Yeah, exactly right. Yes, you can think of it that way. Exactly right. Okay, so those double roots. Now, of course, if you have a triple root, then it would continue on through as you would expect it to. So, like, I guess more of you want to think about like an even-powered root, or if a root occurs an even number of times, I guess I could say in a different way, right? Then you would expect it to hit and then come back down, right? If, however, you have an odd number of occurrences of that root. So 1 is the most typical one we see, right? Every root normally occurs just once. That's why it goes through, right? Or if it's if it happens 3 times, also we'd expect it to go through too. So yeah, but that's right. Yes, that'll be helpful there to see that. So yeah, here we go, right? Okay. So again, just some other questions I want to make sure that we're okay with, right? How many? Do we have any relative minimums here? Do we have a relative minimum? Yes. How many does it look like we're going to have? Just 1, right? Okay. It is not, again, it is not at this point, right? This is, again, the best we can do without calculus, okay? The relative minimum is going to be somewhere between these two zeros, okay? We know we have to go down to this point and then back up, right? And so we expect then there must be a relative minimum somewhere in here. But again, it won't be this point. Because actually, if anyone tried x equals -1 here, you do end up going lower than -64. So some point lower than that, but anyway, you get the idea, okay? Is this relative minimum, will it also be an absolute minimum? No, right? Because again, we keep going lower than that, so none of these are going to be absolute minimums. Okay. Do we have any relative maximums? Yes, where? At the zeros, right? And these we can identify as relative maximums, okay? Because those are exact points we know are on our graph. And so this is a relative maximum, this is a relative maximum, okay? Do we have any absolute maximums for this graph? Yes. Where are they? At the zeros. Wait a minute, Mr. Wade, we have 2 places where the relative maximum occurs? Yes. Or sorry, the absolute maximum occurs? Yes, okay? Both these places you could consider to be an absolute maximum because they both have the same highest y value of, well, 0 there, okay? So the absolute maximum value is 0, and the location of those absolute maximums are at 2 and -4 there. Okay. So 1 relative minimum somewhere between these 2 zeros. We're not exactly sure where without calculus, but at least we know it's going to happen in here somewhere. So 1 relative minimum. 2 relative maximums because of the hills there. They're precisely at those 2 points because those are points on our curve there, and we know that's the highest it's going to go, okay, because of the way the graph is shaped. All right, and they're also then absolute maximums because those are the highest points, right? We don't go any higher than that. Okay? So, any questions on any of that? We'll do one more here. Okay. Very good. All right, so let's try another one then. Y equals x to the 4th plus 5x cubed minus 6x squared. Okay, that's going to be our polynomial there. All right, so let's find the zeros. So we'll set this thing equal to 0. Okay, just like we did before, set it equal to 0. But now what do we have to do? In order to solve this, what do we have to do? Factor it, that's right. So Riley, since you said factor, right, can you identify what's something we could do here to start factoring? What's a strategy we could use? Or what's something we could take out?
X squared.
Okay, so it's a GCF, right, exactly right. So we're going to use that GCF to factor it out. We're left with x squared plus 5x minus 6. Okay. And then can we factor further here? Is there anything else we can do? This is for everybody. What do you guys say? Can we factor further? Yeah, okay, what can factor? X squared plus 5x minus 6. Okay, what will that factor to be? So yeah, it's going to be x plus 6, x minus 1, or x minus 1, x plus 6. Yeah, it's like, got to be careful. I know, right? But I mean, that's hard. That for whatever reason, people that one gets tempting, I guess, because it's either the 3 or the 2, or it's the 5 and the or 1 and the 6, and I just, and it can be tricky. But that's it. That's what it does factor to be there. Okay, so do be careful. All right, and so then we get x is 0, x equals -6, x equals 1 as our zeros there. Okay, so we have 3 zeros, and so when we go to do our middle behavior here, I'll put these again in order from -6 to 0 to 1. Okay, I got to pick something here between -6 and 0, so I'm going to use -3. And between 0 and 1, fractions, right? I'll use 1/2. Okay, so we'll evaluate y at x equals -3, and we evaluate y at x equals 1/2. Okay, so we'll plug in the -3 there. You can plug it into whatever version of this you want. If you like, I think the factored one might be a little bit easier to do arithmetic with, like the mental math. The non-factored one, you can still do it that way, but I'm going to use the factored version. Okay, so when I plug in the -3, I get 9 times 3 times -4. Okay, so 9 times 3, 27. 27 times -4. Well, let's see, times 2 is -54. So times another 2 would be -108. Okay, and then 1/2 squared would be 1/4. 1/2 plus 6. Maybe this isn't easier, but that's okay. 13 halves. And then 1/2 minus 1 will be -1/2. Like that. Which, if we multiply all that together, -13 over 16. Okay. And so we have then -3 comma -108 and 1/2 comma -13/16. Okay. Again, fraction arithmetic right there, or fraction arithmetic, when you multiply, right, you multiply across the top, multiply across the bottom. Those improper fractions, right, super helpful when it comes to that. Okay. And again, if you don't like fractions, right, I recommend you challenge yourself to, at least try and do them, okay, because you're only going to get better at them by practicing them. Okay, right now it doesn't hurt at all to practice your fractions, right? There's no harm in you getting something wrong. It's on the tests or on the quizzes, right, later if you mess up those, right? So practice them now. Don't just, run to your calculator and start typing them in. Okay? Try them now. All right, anywho, we got that information. We got one more thing we got to do, the end behavior. I don't quite have enough room, so I'm going to do it over here at the top. All right. And so we'll say as x approaches infinity and as x approaches -infinity. And this time I will use y's just because you can. Okay, it makes more sense here. We didn't really call this thing f of x. So. Okay. What is the degree of this polynomial? It's even, right? So, 4, or it's even. Very good. Okay, what's the lead coefficient? Positive, right? Okay, so it's positive and even. All right, so even, that means either they both go up or they both go down. And then it's positive, so that means they're both going to go up to infinity and beyond, right? All right, so we're both sides will go to positive infinity there. And then we'll finally sketch this thing. Again, trying to keep in mind here, I have to go down to negative y value, or y value of -108. Ugh. Okay, and then my x values aren't too crazy there. That's weird. I have to do y value of -108, but I also do a y value of -13/16. So I have to have like a very large scale, but also simultaneously a very small scale too. So this is what happens sometimes. So we'll just kind of try to make the best of what we can. Okay. X, y. So let's see here. So we've got 0, and then 1, 2, 3, 4, 5, 6. Okay, so there's -6. There's 1. Okay, we got all that. So 0, 0, -6, 1, 2, 3, 4, 5, 6. X equals 1. And then for my y-axis, well, I guess I'll count by tens if I got to go down to negative 108. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, so negative 108 be negative 3, negative 108. So 1, 2, 3, negative 108. Like right here somewhere. And then 1 half, negative 13 16. So 1 half and then negative 13 16ths, it's like almost negative 1. So something like that. Okay, it's not going to be super pretty, but again, we'll connect the dots here at least. Okay, hit that. We got to go back down, hit that, and then back up. And then we're both going to positive infinity, right? Both the right hand behavior and left hand behavior. So we're going to just go up through that and up through that, like that. Okay. So, how many relative minimums do we have here? 2. How many relative maximums do we have? 1. Okay. Do we have any absolute minimums? How many do we have? Absolute minimums. Trick question, right? Just 1, right? There's not going to be more than 1 here. You can only have more than 1 absolute minimum if you have more than 1 point that's kind of like at the same lowest kind of point, right? We had 2 absolute maximums here. Whoops, I froze it. We have 2 absolute maximums here because they are the same height, right? They're both the highest point, and they're at the same height there. But here we only have 1 lowest point. And again, is this the place? Not quite, right? Somewhere between here and here, we're going to have that absolute minimum value. Not necessarily right here. We can't figure it out without calculus and stuff. And again, if that's something you're interested in, I can show you kind of like how to find that. If you're interested, because we'll have plenty of time here in class, maybe. Okay, do that if you're interested. Okay. But anyway, questions on any of that? Oh yes, Ramike, sorry. Go ahead. In this graph, how many do you think we have? 1. Yep, just 1. Right there at the origin. Yep. How many absolute maximums do we have? What do you think, Cooper? 2? Where are they? Give me like the x coordinates or something. So let me just pause here real quick. Absolute maximums are the locations where the graph is at its highest point and goes no higher.
So you don't include the errors?
Well, that's just it, right? So our graph has the end behavior that goes towards positive infinity. So it's impossible to go bigger than infinity, really, right? Or in a sense. So there are no 0 absolute maximums. There is, however, a lowest point, right? The absolute minimum is right there. Well, sorry, not right there, but again, in that interval, it's going to happen. There will be an absolute minimum. Does that make sense?
Yeah.
Okay. Any questions on any of that? Any other questions? All right, so let me get you guys then started on a few problems here to try. I'm going to give you 3 of them, okay? 3. Okay, so again, your directions will be sketch the graphs. And I'll kind of come around and help as necessary. Okay. You may use your calculators to help you, but I would suggest that you do this all on your own and then check it with your graphing calculator, okay? Don't just, type in your calculator and say, "Oh yeah, that's what I would have gotten." All right, so I'll be nice. They're already all going to be factored for you there. All right, so give those 3 a try there, okay? Give those 3 a try. right there. So you sort of, I see what you're saying. So, we honestly, we can't come up with an exact value for that. We can't know exactly how low or how high, but what we do is we pick a number in between, so like 0 will be good for that one, right? You're gonna plug 0 back in. That'll then give you a matching y coordinate for your 0 x coordinate. Yeah, so the point that you find is an actual point on the graph. Okay? It might not necessarily exactly be the highest or lowest point, but it's definitely on your graph, so you can definitely like connect it, but then whether that is the highest or lowest, kind of thing, or if it's relative next to it, that's, potentially, yes. I mean, yeah, and you could pick really any number between these two, so I will have a little bit of work on my own part to do that, but hopefully, most people pick them.
I was just you were coming up with the numbers of those.
Yeah, no, I'm just picking any number in the interval there. Generally, I like to go for like something in the middle, like very close to the middle. So like 0 for this one, here 3, kind of thing. But that being said, you really could use any number. A very interesting story. I don't know if I've read the story, but I actually know that. Yeah. Okay, so 0 and 3 sounds good to me. Yeah, those look good. Those points, yeah. Did you have behavior yet? Actually, you probably want to figure that out. So, yeah, as x, yeah, so go to the right, you should go to the left, so left, yes.
For number 3,
Yes.
so the degree would be odd, and my coefficient is negative, so she goes down. But Mr. Walker taught us something about
Multiplicity. Yeah.
and it should say
It's just exactly the same.
I would say, y'all doing okay over here?
Yeah, I'm just stressing
Solid.
out.
Stressing out.
Yeah, he's stressing me out.
Waffle House is not as good as IHOP.
It's
Okay.
the same,
That's
they're
the
different,
opinion.
they're completely different, and they're the same.
How about you try this one right now first? Okay. This is math class, not a restaurant class.
Yeah. Mr. Ryan.
Yes. Yes.
Yeah,
Is this the first one here?
yeah, is that right?
So first wait a minute, what am I looking for? Sorry. This one.
That's the second one.
That's the second one. This is the
Yeah.
first one.
Yeah,
You're
that's
looking-
the
this is
first
the
one.
okay, gotcha.
Yeah,
Okay.
sorry.
I understand. No, I'm sorry. When you put C, I was like C, but now it makes sense because we did
No,
two
yeah,
examples.
yeah,
And yeah, I understand. No. All right, that looks good. That looks good. So far, so good. Yes.
for this is the middle
So, careful, these are not equal. So I like to rewrite the word first, so that way, yeah. Otherwise, you're gonna get your Thank you. saddle points yet? All right, you'll learn about those at some point. That's all. I don't know. The plastic just kind of like, I don't know. It was packed in stuff, so it maybe like vibrated or rubbed, you know? That's what I'm thinking. All right. See what I can do for you.
So, I'm confused on middle being.
Okay.
So, put -1 here.
Negative 1, 2. Yeah, or negative 2 is what it would be.
Negative
Yeah, watch your signs. I would say so. Maybe let's check it. Make sure you're
So if you put -1 there.
1 minus negative 1 is positive 5.
Oh, positive 2?
Yeah, because it's 1 minus a negative 1.
Okay, yeah, okay. So it's 1 solid negative? That is correct.
So 1/2, you plug that in.
Well,
Did you do your math?
well, that's the top half.
Say again.
Well, that's the top half.
Might not be. Yeah, so you should do that fraction right there. Is that you being excited at the prospect of doing fraction? So you got a 1/2 here. You're gonna do 1/2 plus 2. But 2 is the same thing as 4/2. 1/2 plus 4/2 is 5/2. Right? So 1/2 times 5/2, and then 1 minus 1/2. That's just gonna be 1/2. Right? So that's what I'm gonna multiply across the top, multiply across the top. Easy.
Because you do the 0.
Yeah, looking good. The shapes look good. I'm like,
Because it's a negative 4. Because 0 minus 4 is negative 4, so it's a negative 4.
okay, give up. You got a question?
Never mind, I think I fixed it.
Okay, you got it now? Yeah, you're close. This behavior was right. It's just this little behavior right here. This piece is
Yeah,
also straight.
right.
Just that little 0. Did you find that Cassie made it into Virginia Tech or not? 5 o'clock. So she missed school because right. Sorry, but
No,
So she went-
She's on a tour at Thompson,
oh right, okay.
but she like didn't want to go to school anymore, so she was like, "Oh, what do you think to do to go to Thompson?"
Yeah, it's great. It's just like the day before our test, so it's no big deal.
Really?
Yeah. No, she didn't know that because, well, actually, let me think
Well,
here.
Friday.
Today was supposed to be the test. Cassie.
How's she doing?
Choices.
How's
Choices.
she doing?
I don't know. You have to ask her. We'll see.
Are you just saying that's just confidentiality?
No, it's more like she's, I don't know, I can't remember even how she did on the last quiz or anything.
I'm just curious. Like, I was like,
Yeah.
but some of us don't like this.
I don't think she probably does either, but. Okay, so there's number 1. I wasn't super accurate with the y values there, but I just wanted to give you the basic shape of the graph. Okay, you guys hopefully can know whether you graphed your y values accurately or not, but there is the shape of number 1. Okay, with the appropriate zeros. Again, you might have selected different points to find for your middle behavior, right? Okay, to find what's happening between the zeros there. But I chose, again, I tried to go for like the midpoints. Okay, not necessary, but there it is. Okay. All right, I'll do the same thing here for number 2 then. So again, I use -1, and then give you -2 then, and then 1/2 give me 5/8, okay, for the middle behavior there, and the graph is going to, oh, sorry, end behavior, whoops. End behavior here. D. So let's see here, -1, 1. Okay, so 0, 0, 1, 0, -2, 0, and so it's going to look something like that. Okay, so the shape of your graph. For number 2. Okay, and then number 3, the last one there. The x-intercepts are 0, 0, and -3, 0. Again, the middle behavior, I chose just -3/2. So again, I went for the exact midpoint there, but I'm going to guess most people didn't do that, okay? But I'm going to use it because that's what I have written down here. Okay, so -3/2, and that gives you then 27/4 if you use that point. And then the end behavior. Okay, here the degree is 3, right? That x is being squared, so it's degree 3. X squared times an x gives me x cubed. So it's a cubic, but it's a negative lead coefficient. So then we're going to go to -infinity as x goes to infinity. And as x goes to -infinity, f of x will go to +infinity. Okay, and so then the shape of your graph is going to look something like this. 0, 0, and then 1, 2, 3, 0. Okay, it's going to look something like that, and then that, and that. Okay? It shouldn't really be pointy like that. It should be kind of nice, smooth transition there, a smoother transition than that. But you get the idea. Okay? And so there's number 3. Questions on 1, 2, or 3 there? Yes, Ramike. Say one more time, start. A higher relative maximum? Yes, that's fine. Yes, yes. And again, because understand any of these relative extrema, unless they occur at zeros, okay? So we do, for example, know for sure that we have a relative minimum at this point right here, okay? Because that occurs at a 0, so we can know for sure there is a relative minimum there. But anywhere else, we're not going to have quite enough skills to do that. Okay, just we don't have quite enough skills to do that. All right. So, questions on any of that? Okay. So your homework is posted to Google Classroom. There's, I think, 4 problems there for you to look at. All right. So why don't you go ahead and get started on that. Or if you didn't get your TenMarks done, make sure you get that done too. And Ryan, I can get you your login information and that jazz. Okay. We'll be here.
Sounds good.
Dropping papers.